Every ambitious project eventually hits a technical wall. You might have a clear vision for a new application or a complex engineering fix, but if you lack the specific coding skills to build it, the idea remains a draft. Early AI models functioned as passive consultants. They could offer snippets of code or suggest architectural changes, but the user still had to manually assemble the software, debug the errors, and physically execute the work. A new benchmark called the Agent's Last Exam measures a different level of capability. Instead of testing whether an AI can answer a difficult question, it tests whether the model can actively manipulate a workstation to complete a project. To pass, the AI receives a high-level task and access to professional software like Unreal Engine or Siemens NX. It must independently reach a correct final result by planning its own actions and operating the software without human intervention. Success on this benchmark indicates that the model has transitioned from a text-based advisor to an autonomous operator. OpenAI designed GPT 5.6 Soul to function as a digital worker bee. It is engineered for rapid, repetitive execution rather than serving as a slow, high-level management model. This chart shows the cost required to achieve top-tier digital intelligence. While a premium model like Claude Fable 5 costs over $21 for a set volume of work, GPT 5.6 delivers similar results for $8.40. This price point allows the model to work through long, complex assignments by trial and error. In benchmarks like DeepSuite, the AI explores unfamiliar codebases and runs its own tests, debugging its own failures until the engineering request is resolved. When technical execution operates at this speed and price, building custom software shifts from a major capital expense to a routine overhead cost. We can see the impact of this shift in the story of Three Wishes cereal. The founders needed a sophisticated corporate dashboard to track their pumpkin spice launch, but they didn't have a technical co-founder to build it. They gave the AI their brand guidelines and a 5-minute voice prompt describing their needs. The system instantly output the necessary data slices and coded a professional command center that would normally require a dedicated engineering team. This capability extends into the physical world. In Hokkaido, a broccoli farmer named Hiroki wanted to automate his farm, but lacked a background in mechanical engineering. He needed to control the electric motors that vent his greenhouses. Hiring specialized agricultural engineers for a custom system was prohibitively expensive. Hiroki used the model to read his database and write the code to independently operate his greenhouse ventilation system, right here in these actual fields. The AI acts as a bridge between a person's intent and functional software, allowing non-technical users to build their own bespoke mechanical systems. Even in high-level mathematics, these agents are solving long-standing bottlenecks. One mathematician spent 3 years trying to disprove a complex algebraic conjecture using traditional methods without success. When he presented the task to the new model, the AI identified the massive computational load and automatically spawned sub-agents to divide the work. By coordinating this internal team, the system successfully processed the calculations and disproved the 3-year-old conjecture in a single afternoon. This process is supported by Generative UI. Instead of simply providing an explanation, the model codes a custom, interactive visualization on the fly, building the specific tools the user needs to understand or manipulate the data. Users are interacting with a system that identifies its own computational bottlenecks and builds the necessary interactive tools to solve them. The most significant integration is ChatGPT for Work, where the AI leaves the web browser to interact directly with the user's desktop environment. By reading local files, the AI can break down multi-hour technical projects and execute the steps independently, working in the background while the user focuses on other tasks. This level of integration allows a single prompt to generate an entire video game or even a detailed procedural voxel-based Manhattan that took the model a week of independent work to construct. Complex projects that once required a technical co-founder or a full development team can now be initiated and completed by a single person with a desktop computer. Using an $8 digital worker to handle high-level technical execution has a direct impact on the person running the project. The cereal founders, the farmer, and the mathematician all offloaded their engineering bottlenecks, which allowed them to redirect their focus toward their families and the core creative ideas of their work. As technical execution becomes a cheap and accessible commodity, human imagination becomes the primary constraint on what a single individual can build.